Your 14.1 part 2 is just a continuation from 14.1 part 1. However, if you remember in part 1, we worked with permutations, which meant that your order matters. With this part of your lesson, you're dealing with combinations, which just means that your order doesn't matter. So two different things: permutations, order matters; combinations, the order does not matter. With these, you're going to use the exact formula that you were using before back in chapter 13 with your n factorial over r factorial times n minus r factorial. These are the ones with the combinations. Okay. If we look at your first example before, let's look at this. It tells you that the key difference between permutations and combinations is the order. So exactly what I just said. Your permutations, your order matters. Your combinations, the order does not matter. So first example tells us that a club has 9 members in it. And how many ways can a committee of 3 be chosen from the members of the club? So this one gives you a combination. The order doesn't matter. So it doesn't tell you that there's a president, a vice president, and a secretary. It just says there's 9 members in the club, and you're picking 3 to be within these chosen members. So you're working with a combination. Because there is 9 members, that 9 is going to go on the top, so it'll go down first. And because you're picking 3 members, that 3 will go down last. So this just means you'll have 9 factorial over 3 factorial times 9 minus 3 factorial. Up top, it's going to stay 9 factorial. On the bottom, you're going to have 3 factorial times 6 factorial. So that 9 factorial is the same thing as 9 times 8 times 7 times 6 factorial. And the reason why we're stopping at the 6 is because the bottom has the 6 factorial. Other than that, on the bottom, you have the 3 times 2 times 1. So because the 6 factorials on the top and the bottom, they cancel out, the 9 times 8 times 7 gives us 504. And the 3 times 2 times 1 gives us 6. 6 goes into 504 84 times. So that's 84 ways that those 3 members can be chosen. If we move on to another type of example, we are going to be looking at a couple different things happening within one instance, to where you're using both your permutations and your combinations. For this example, it tells you that a committee of 7, so that's your total, consisting of a chairman, a vice chairman, and a secretary, and 4 other members. So you have different jobs that are happening here. So it tells you that they're to be chosen from a class of 20 students, and how many ways can the committee be chosen? So you have a total of 20 students to choose from. So that number that you're going to start with for your combination is 20. Now, if you look here, the different jobs that we're looking at are the chairman, the vice chairman, and the secretary. So there's 3 positions there. So that means 3 positions out of 20 people. For the other instance, you have 4 members that can be chosen at random. So, sorry, this one is a permutation, not a combination. This is a permutation because there's 3 distinct titles there. For your combination, though, there's those 4 other members, which don't have specific titles to, but you're going to use them within what's left over. So if you subtract the 3 that you've already chosen for the chairman, the vice chairman, and the secretary from the 20 that you started with, that's a total of 17 that you can choose from. Out of that, you're picking 4 members. So you're going to solve for the permutation first. So remember that permutation, you're going to do the 20 factorial over 20 minus 3 factorial. For the combination, you're doing the 17 factorial over 4 times 17 minus 4 factorial. And you're going to multiply these. So if we simplify, we're going to be doing 20 factorial over 17 factorial. And for your 17 factorial over, let's do this in the same color. 4 factorial times 13 factorial. So if we rewrite the one that's in orange, you're going to have, I'm going to bring this up here, 20 times 19 times 18 times 17 factorial over 17 factorial. For the blue, we have 17 factorial, so that's going to be 17 times 16 times 15 times 14 times 13 factorial, all over the 4 factorial, which is 4 times 3 times 2 times 1 times 13 factorial, which we have up top. For the one that's on the left in the orange, the 17 factorial factors out or cancels out on the top and the bottom. So you just have 20 times 19 times 18. For the part that's on the right, which is the blue, your 13 factorial cancels out. So you're going to have 17 times 16 times 15 times 14 over 4 times 3 times 2 times 1. If we simplify this, the 20 times 19 times 18 gives us 6,840. And the 17 times 16 times 15 times 14 gives us 57,120 over 4 times 3 times 2 times 1, which is 24. That 57,120 divided by 24 simplifies to give us 6,840 times 2,380, which gives us a total of 16,279,200.